friends, good evening. I am Gaurav Gupta and I welcome all of you once again to BYJU'S exam prep, formerly known as Grade Up. Now friends, BYJU'S exam prep is the most comprehensive app for all the examinations including CAT and other MBA entrance examinations. Now here at BYJU'S, we provide our aspirants with end-to-end preparation so that all of you can achieve your dreams. Now I am Gaurav Gupta and we are going to continue with the series of ratios that we have started a few days back. Okay, now if you all have attended my sessions yesterday, we have started with mixtures and alligations, which is nothing but the applications of ratios. And I have told all of you that in today's lecture I'm going to take the concept to another higher level and we are going to discuss the concept of removal and replacement, which is one of the, like I can say, a complex, a difficult concepts in the chapter of mixtures and alligations. All right. So friends, let's start with the concept of removal and replacement in today's lecture. Okay. Now again, like yesterday, what we did basically was we took some of the questions and through these questions I tried to explain you all the logics. Okay. Now I have kept basically the concept, the flow of this lecture in the similar manner. Okay, so I have picked some of the questions using which I'll be explaining you each and every concept of removal and replacement. All right, so let's look ahead and first of all, a small recap to yesterday's session. Okay, so I'll start with a very small question, a very easy question, in which the concept that we have covered yesterday will be required. Okay, so let's have a look at this question very quickly. All right, so the question says that Ajay invests rupees 3 lakhs in two schemes. Now friends, we have already covered this particular concept in yesterday's lecture. Okay, so I'm just giving you a small recap so that you can recall these things. Okay, so Ajay invests rupees 3 lakhs in two schemes, scheme X and scheme Y. So there are two schemes in which he has invested a total of rupees 3 lakhs. Now this question will also help you in understanding one more application of allegations. Okay, now at the end of the year, X and Y gives a return of 31% and 41% respectively. So I can say that scheme X has given a total return of, scheme X has given a total return of 31 percentage. Okay, and scheme Y has given a net return of 41 percentage. So in this case, they have given the individual returns given by scheme X and scheme Y. Okay, also his total earning from the two schemes is given as 1,05,000. Okay. Now, what was the total money that he invested? He invested rupees 3 lakhs, and the net return, the total return in terms of rupees from both the schemes is rupees 1,05,000. Okay. Now, let's consider this data that I have marked with red color. Okay. So his total investment was 3 lakhs. Okay. And his return is 1.05 lakhs. All right. Now we'll calculate what is the percentage return he has received in all from two schemes combined. Okay, so in terms of money, he has received a return of 1.05 lakhs on a total investment of 3 lakhs. Okay, so I'll convert this particular thing in terms of percentages. So 1.05 is what percentage of 3 lakhs? This is what first of all we have to find out. So using this very simple calculation, I can do that. Okay, so you will get 35% as the answer. All right, so 1.05 is 35% of 3 lakhs. All right, so I can say that from scheme X, his percentage return was 31%. From scheme Y, his percentage return is 41%. Okay, overall combined return in terms of percentages that he has got is 35%. I'll put it here and will apply allegations to find out the ratio in which he has invested the money in these two schemes. Okay, so applying allegations, so 41 and 35, the difference is 6. 31 and 35, the difference is 4. So I can say that the ratio here is 3:2, which is the ratio in which he must have invested in these two schemes. Okay, now we have a total of 3 lakh rupees, which will be divided in the ratio of 3:2. So I can say that in scheme X, his investment is 1.8 lakhs, and in scheme Y, his investment is 1.2 lakhs. So in the last step, what I have done is, hi Monish, good evening. So in the last step, what I have done is I have divided 3 lakhs, which is the total investment, in the ratio of 3:2. All right. So this is what we have to calculate. How much did he invest in each scheme? So he has invested rupees 1.8 lakhs and rupees 1.2 lakhs in these two schemes respectively. All right. So this is basically another application. You could have solved this question using ratios completely. You could have made the equations, but if you will go with this type of method applying allegations, then certainly the solutions will be less lengthy and it will be less complex. All right. Okay. Now let's talk about today's concept, the concept of removal and replacement. Okay. So let's have a look at one of the easy questions, one of the basic questions of removal and replacement, where we can apply this thing. Okay. Now, question says that a vessel contains milk and water in the ratio 3:4. When 6 liters of this solution is removed and replaced with water, okay, the ratio of milk and water becomes 5:9. The question is, how many liters of the solution was present in the vessel originally? All right. So this is the basic question. Now I can say that this question can be done in a lot of ways. Okay, so if you will use basic ratios, if you'll assume some basically capacity of this vessel and divide it in the ratio of 3:5 in milk and water, then remove 6 liters of solution and replace it with water, 6 liters of water, okay, and equate the final ratio of milk and water as 5:9. Okay, so that will be a little lengthy process. Okay, that will be a little lengthy process. Okay, so wonderful. So Raj, Payal, both of you have also joined. Wonderful to see you each and every day. Okay, so let's talk about how to apply the concept of removal and replacement. Now, basically, first of all, we need to understand when we are removing something, then we are removing some liters from the total capacity. Okay, now this can be converted in terms of percentages or in terms of fractions. All right, now the concept of removal and replacement is nothing but the concept of percentage change. All right, it is no more than the concept of percentage change. All right, so whatever we have done in previous lectures in percentage change, percentage increase, percentage decrease, all those concepts will be applicable here. All right, each and everything will be applicable here. All right, okay. Now, first of all, I'll look at this thing. The ratio of milk and water initially is 3:5. So now again, either will be applying this percentage change on milk or it will be applied on water. Okay, now how to decide on which entity we have to apply this percentage change? It is decided by basically the replacement, using which the replacement is being done. Okay, so let us understand on which entity, either milk or water, we have to apply this particular change. Okay, now question says that 6 liters of solution is removed, okay, and is replaced by water. Okay, so now if replacement is done by water, listen carefully, if replacement is done by water, then we'll be applying all these formulas, all these changes on milk. Okay, will not apply it on water. All right, so if replacement is done by water, we'll apply it on milk. If replacement is done by milk, then we'll apply it on water. All right, okay. Now let's have a look at the formula or the basic concept here. Now we have seen in percentages that, let's say if anything which is x is decreased by 20 percentage, Okay, so the final value is 20% less than the initial value. It can be written as 0.8x, all right, or it can be written as 4 upon 5x. All right, now reduction of 20%, what do I mean by that? A reduction of 20% means something is reduced by 1 by 5 of its original value. Okay, so there is a reduction of 1/5. Okay, there is a reduction of 1/5. So if I reduce something by 1/5, then the leftover quantity will be equal to 4/5 of the initial value. All right, so this particular thing you have to understand. All right, okay, so now here what concept I will use is the final concentration. The final concentration, instead of concentration you may write fraction as well. Okay, so in the above question it will be final concentration of milk or final concentration of milk or final fraction of milk, okay, will be equal to initial concentration or fraction. Okay, initial concentration or fraction of milk. All right, so if you are using concentration, then I'll keep concentration on both sides. If you are using fraction, I'll put fraction on both sides. Okay, so final concentration will be equal to initial concentration multiplied by the leftover fraction or the final fraction. All right, now leftover percentage you can put, or leftover fraction can be substituted. Okay, so I'll write leftover fraction. All right, so this leftover fraction can also be calculated in one manner. So I'll write that particular thing as well. Okay, so it is total solution minus the value or the quantity which is removed divided by total solution. Okay, so basically in the numerator I have leftover quantity, in the denominator I have total quantity. All right, so leftover quantity divided by total quantity is the fraction of solution which is left. Okay, fine. So now let's apply this particular thing. So let's apply this particular thing here. Now final concentration or fraction. So let's read the question. So a vessel contains milk and water in the ratio 3:5. Okay, so if I talk about the fraction of milk, it will be 3 upon 8. The fraction of water will be 5 upon 8, right? Now 6 liters of solution is removed and replaced by water. The ratio of milk and water finally becomes 5:9. How many liters of solution was present in the vessel originally? So basically we have to find the capacity of the vessel. Okay, now I assume that the capacity of the vessel originally was X liters. All right, I'll erase something which is not required. Okay, so I'll assume that the initial quantity or the initial capacity, the total capacity of the vessel was X liters. Okay, now let's feed some of the values. So first of all, I need to find final concentration or fraction of milk. Since the replacement is done by water, I'll be applying all this formula on the value of milk. Okay, so final fraction of milk. So this is the final ratio of milk and water. So what will be the final fraction of milk? Can you all write it in the chat box? Come on. So final fraction of milk. I'm writing it now, 5 upon 14. So this is final fraction of milk. That is equal to initial fraction of milk, which is 3 upon 8 bracket. Total solution I have assumed as X minus what is the quantity which we have removed? We have removed 6 liters divided by total solution. So basically this is nothing but the percentage or the fraction of solution which is left. Okay, now if this particular thing is done once, I'll leave it as it is. If this step is repeated n number of times, I'll put the power of this bracket as n. Okay, that will tell you how many times this particular process is repeated. So in this case, this process is repeated or done only once, so the power will be 1. Okay, now you can do cross multiplication and get the value of x. Okay, so I'll do cross multiplication. 40x is equal to 14 into 3 is 42x minus 14 into 3 into 6. All right, so I can say that the value of 2x will be equal to 21 into 6, that is 126 liters. So this will be the value of x. So the value of 2x will be 14 into 3 into 6. Okay, I have cancelled 2 from both sides and the value of x will come out to be 126 liters. All right. Okay, now I'll repeat a few important points once again. So basically we are looking at the concept of removal and replacement, where we remove some part of the solution and replace the same quantity. Okay, replace it by either water or milk using the same quantity. All right, in this question we started with a milk and water solution which are present in the ratio 3:4. Okay, we removed 6 liters of the solution and replaced with water, such that the final percentage or the final ratio of milk and water became 5:9. Now we have to find out the total capacity of the vessel or the initial quantity of the solution in the vessel. Now we have used the formula final concentration is equal to initial concentration multiplied by total solution minus the solution which is removed divided by total solution. Okay, and power will be n raised to the power number of times the step is repeated. What I am saying is this is nothing but percentage reduction. All right, so final concentration or fraction of milk is equal to initial concentration or fraction of milk multiplied by the fraction of solution which is left. So in the numerator, I have kept x minus 6. X was the total solution. 6 was the quantity which was removed. Okay, so x minus 6 was the leftover solution. When divided by total solution will give you the leftover fraction of the solution. All right, just simplify this and get the answer. All right, chaliye आगे चलते हैं. Let's look at the next question. The question says that a vessel contains 75% milk solution. So initial concentration of milk is given. 20% of the solution is removed and replaced by water. So if I'll remove 20%, then can I say that I'll be left with 80%? Yes. Okay. So leftover fraction will be 80% or 80 upon 100 or 4 upon 5. Okay. Now this particular process is repeated 2 more times. We have to find the percentage of milk in the solution after 3 such operations. So once it is done, then this process is repeated 2 more times. So that means this process is done a total of 3 times. So we have to find out the percentage of milk in the solution after these 3 operations. Okay, now all of you can take a lead, quickly solve it. I will be solving it a little slowly. Okay, so the final concentration of milk will be equal to, now important thing is replacement is done by water. Okay, I'll write it again. So replacement is done by water, so formula will be applicable on milk. Okay, so I have to write final concentration of milk, that will be equal to initial concentration of milk bracket the leftover fraction raised to the power number of times the step is repeated. Okay, now initial concentration of milk is given as 75. In the bracket, what should I write? 20% of the solution is removed. That means 1/5 of the solution is removed. Okay, so if 1/5 is removed, then the leftover fraction will be 4/5. Okay, so I'll put 4/5 here and power will be 3. A total of 3 times this step is repeated. Okay, so let's simplify this. 75 multiplied by 4/5 multiplied by 4/5 multiplied by 4/5. So these two 5s will get cancelled and यहाँ पे कितना आ जाएगा? It will be 3. Okay, so 4 into 4 into 4, that is 64. 64 into 3 is 192 divided by 5. Now 192 divided by 5 will be 38.4. So 38.4 percentage, 38.4 percentage will be the final answer. All right. So the calculations are not that important, but the expression that I have written here is more important. Okay. So you must understand, in the brackets, we will write the percentage or the fraction of solution which is left over. So I've removed 20%, I'll be left with 80%. 80% can be written as 4 by 5. Simple. All right. Okay. Now let's look at one more question of the similar type. Now the types are similar, but in every case, there is something which is new. Okay. Now a worker at a factory steals 10 liters from a container full of honey. Okay. Now we have to find the total capacity of the container. So I'll assume that initially X liters of honey was present. Okay. Now he removes 10 liters from a container full of honey. Now, since initially the container is full of honey, so I can say that initially the percentage of honey will be 100% or the fraction of honey will be 1. Okay, because it is pure honey that is present. All right. So if I need the concentration of honey initially, that will be 100%. If I need the fraction of honey which is present initially, that will be 1 because it is pure honey. All right. Okay. Now he removes 10 liters of honey and replaced it with 10 liters of water. So again, replacement is done by water. So final fraction of honey or final percentage of honey is equal to initial percentage. All right. Bracket the leftover fraction raised to the power number of times the step is repeated. Okay. Now he repeats this process again, and the ratio of honey to water now becomes 49 is to 32. Okay. Now the process is repeated a total of 2 times, after which the ratio of honey and water becomes 49 is to 32. Now this is the ratio of honey and water. This is the ratio of honey and water. All right. So what will be the fraction of honey? I'll give all of you a chance. So quickly write it in a few seconds. What will be? Monish, thoda sa ruko. Okay. So what will be the fraction of honey present here? So Monish, focus on this one. I'll go back to the previous one. Okay, later on. So the fraction of honey will be 49 divided by total quantity, 49 plus 32. So that is 81. All right. So 49 divided by 81 will be the final fraction. What was the initial fraction since I had pure honey? So initial fraction was 1. Bracket total solution, I'll assume it as X minus the quantity which is removed divided by total solution and raised to the power the number of times the step is repeated. So in this case, it is repeated 2 times, the power will be 2. Okay. Now I can take square root on both sides to solve this. So 7 upon 9 will be there on the left hand side and x minus 10 divided by x on the right hand side. Do cross multiplication. So 7x equals 9x minus 90. So the value of x will come out to be 90 divided by 2, that is 45 liters. So the question is, what is the total capacity of the container? I can say the answer will be 45 liters. All right. So have a look at it. If you have any confusion, please ask me. Meanwhile, Monish, you can tell me what is the confusion, what is the query regarding the previous question. Quickly type it in the chat. Come on, Monish, what is your query regarding this one? Okay, so we can take the fraction of milk as 3 by 4. Yes. So basically, Monish, instead of 75% you are asking, we could have taken 3 by 4. Yes, we could have done that. In that case, so if the percentage is 75% initially, I can write it as 3 by 4. Okay. In that case, I will get the final fraction of milk. Since they required final percentage of milk, okay, so that is why I kept the initial in terms of percentage. Okay, am I clear? All right, now let's move ahead and look at the next question. Okay, so all of you focus on this one. Wait. Okay, now in this case something else is happening. So a vessel contains milk and water in the ratio 2:5. So initial ratio is 2:5. Okay, 10% of this solution is removed and replaced by milk. So here the replacement is done by milk. So the formula will be applicable on water. Okay, so formula will be applicable on water. This is one important thing. Okay, so the initial fraction of water will be 5/7. Now, first of all, we have removed 10% of the solution. So we'll remove 10%. So leftover percentage will be 90%. All right. Then what we did was we removed 30% and again replaced by milk. And finally, we removed 25% and again replaced by milk. Okay. Now, in this case, we are removing different quantities. We are removing different percentages of the solution. Okay. Never mind. So what we'll do is instead of putting the power as n, we will apply the concept of successive change. Okay, so we'll make the separate brackets and we'll keep on multiplying with them. All right, so what I'll do is the final fraction of water will be equal to initial fraction of water, same up till the last question. So initial fraction of water is 5/7. Now first step, I removed 10%. So if I remove 10%, I'll be left with 90%. So I'll write 9/10. So this is the leftover fraction. In the second case, I have removed 30%. So if I've removed 30%, I'll be left with 70%. So again, leftover fraction. And finally, I have removed 25% and replaced by milk. So when I'm removing 25%, that means 1/4. I'll be left with 3/4. All right. So this will be the final fraction of water. Okay. Carefully, this will be the final fraction of water. Now I'll do some cancellation here. So 7 and 7 will get cancelled. 5 and 10, यहाँ पे 2 आ जाएगा. So 9 into 3 is 27 in the numerator and denominator is 80. All right. So this is basically the final fraction of water. All right. Now what we have to find is the ratio of milk and water. Okay. Now in this case, water, if it is 27 out of a total of 80, so what will be the quantity of milk? It will be 80 minus 27. All right. That is 53. Okay. So the ratio of milk and water will be equal to 53:27. Okay. Am I clear? Yes, Siddharth, you may post the question here at the end, whatever you want to ask. No problem at all. Okay, fine. Now, Vaibhav, you have rightly said, but I'll elaborate on it at the towards the end of this lecture. Okay, whatever you are discussing about tests and Excel. Okay, fine. So this is all about this thing. So final ratio of milk and water is 53:27. All of you give me a thumbs up if you have understood whatever I'm trying to teach you. All of you, go ahead. Okay. Now that was it. So if you all like this lecture, if you understood the concept of removal and replacement, if I'm able to basically make this concept easy, please do like this session. All right. Now, Siddharth, you may post a question here. Now, meanwhile, Webhub, you are saying that undoubtedly TIS is at par when it comes to return on investment. Definitely, because there is a difference between the fees of TIS as well as XLRI. But if we are looking at an MBA in HR or MA in HR, so TIS offers MA in HR, which is the flagship course. Okay. Also, if I'll talk about Excel, so Excel offers two programs. One is BM and the other one is HR. Now I can say that if I'll compare XLRI and TIS, now there is huge difference between these colleges. Okay, now TIS is definitely like I can consider this consider XLRI as one of the top B schools. All right. So if I am at your end, I will go for, like, if I'm looking for an HR program, fine, both colleges are good. But if I'm getting a selection in both, then I'll prefer XLRI over TIS. Okay, but my second choice will definitely be TIS. I'm not saying that TIS is not a good option. I'm saying that if I have a convert in both these colleges, XLRI HR program and TIS MA in HR, then I will select XLRI HR program. All right. But the important thing is I should be having convert in both. Okay. Right. So friends, that's all from my side for the day. Okay. Now Siddharth has posted a question. All of you may look at it. Siddharth has posted a question. Okay. Now it says jar P contains 6 liters of 54% milk solution. Jar Q contains 3 liters of 57% milk solution. Jar R contains 1 liter of X percentage milk solution. Okay. Okay, so Y upon Z liters of solution from jar R is transferred from jar P, and the remaining solution from jar R is transferred to jar Q, such that resulting two solutions contain 50% milk. Also, okay, so Siddharth, I'm not going to take this question right now. Okay, so definitely, like, I have left my number, so I'm also leaving my number once again. You can ping me and I'll send you the solution, the complete solution of this. Okay, right now we don't have time. Okay, so we have to end this session. So this is my number. You can ping me and I will send the complete solution of this one, or I'll leave my solution in the chat box. I'll reply you in the chat box. Okay. Definitely this is a very lengthy question and right now we don't have time to look at this one. All right, Webhav. Okay, so friends, that's all from my side for the day. This is the entire schedule on your screen. This is the entire schedule that we run during the week on YouTube. So on the channel of BYJU'S Exam Prep, you can find all these sessions running in the entire week. So please note down this schedule so that you will not miss any of the sessions that you want to attend. All right. Now you can have a look at all the free lectures at one place for CAT, MHCT and all other MBA programs. The link of the same sheet is there in the description of this lecture. Okay, so you can have a look at that sheet and you don't have to search for these sessions on YouTube randomly. So you will find all the topics, all the free lectures of all these topics from CAT, MHCT and all other MBA examinations at one place. All right. Some of the CAT courses and other MBA examination courses that we offer here at BYJU'S Exam Prep. So CAT 2022, we have a complete course. For CAT 21, we have a comprehensive course, which is score 99 percentile batch. Also, there is a percentile booster batch, which we offer for CAT 21. Now we have batch for students who are not opting for specifically CAT, but also opting for other examinations like SNAP, NMAT, CMAT, and TESNET. Okay. Now this is one of the batches of such kind. So you can have a look at the entire details about this batch, which is for SNAP, NMAT, CMAT, and TESNET. All right. And you may join this batch. Further, if you need some more details, you can call at this number and have a look at it. Now, this is the list of experts that we have on our panel. This is the entire list of experts that we have on our panel. The other online classroom programs that we have are for CAT 2021. These are the complete details which I've explained earlier. Also, a complete course for CAT 2022. So again, all the details are on the screen. You can have a look at it. That's all from my side, friends. You can follow us on Instagram, Facebook. You can join us on Telegram. All right. And do subscribe this channel. If you like this channel, please give me a thumbs up and press the like button. That's all from my side for the day. Tomorrow, I am going to start a series on algebra. From tomorrow onwards, I'm starting a series on algebra. So I'll be taking each and every concept of algebra, starting from polynomials to functions, graph, inequalities, modulus, each and everything I'll be discussing in these sessions one by one. All right. So we'll see you tomorrow at the same time. Have a good day. Bye bye.